Yep. Okay. So for the first one, I factored it down. There is no GCF in the first problem, so I pulled an x squared out of the left half, and that left behind x plus 5. And then, so I'm just doing grouping, obviously. And then I pulled a -4 out of the second half. That also left behind x plus 5. So a successful factoring on this should be x plus 5 times the difference of squares. And of course, the difference of squares is x squared minus 4, which by now you know breaks into x plus 2, x minus 2. So any questions on the factorization of it? Okay, so that means that our zeros are, this is a real basic warm-uppy kind of problem. So our zeros are all unique. We have one at -5, we have one at -2, and then of course we have one at +2. So when it comes to like, my quote unquote answer, you want to make sure that you express that, hey, this is something that I'm sending to you. This is an answer, okay? Finding the zeros is like a direct task. So get that done. So now that we have the zeros, we probably want to go sketch an x-axis and a y-axis, and then try to be mindful of scaling. So like I need more negative axis than positive axis. So I pay attention, well, contrary to what you'll see on my answer key. I pay attention to like, how much do I need? So I'm going to need more on the left-hand side. So I'm going to put a 0 at what I'm going to, for now, estimate at -5. I need another one at -2, which is less than halfway to -5. And then I need another one at +2, which is equidistant from the origin. So, and then just throw a quick label on those just for anyone who's interested. So there's -5, there's -2, and there's +2. All right. I know that I started you out not labeling those, but really we should start getting in the habit of doing that. So the behavior on this one is something we also want to write down. So it's not really something that like I'm saying is a final answer, but I think it's good for all of us if we write it down. So because it's an odd power and a positive in front, its behavior is definitely down up. So I'm going to write that down. You'll notice on my key, I just wrote it down and just kind of boxed it up every time, set it aside. And if it's a down up, then I know it has to go down over here on this side. And then it's going to go up on this side like this. So again, you by now understand the power of that, understanding that it just lays the graph right out for us. So our first positive interval takes place right here over that arch, and then our negative interval occurs, oh, my bad, that's really ugly, from right here to like right here. So all right, I'm guessing by now that was just total light work for you guys, like simple pimple, huh? So we're going to say the graph is negative over the intervals from -infinity to -5, comma, and then the other interval is from -2 to +2. And then the graph, of course, is positive over the intervals from -5 to -2, and also from 2 to infinity. Any questions on number one? Okay. Number two, not much more meat on this bone. You do, however, have to pull a GCF on this one. So if you yank the 2x out right at the beginning, you're left with x cubed plus 3x squared minus 9x minus 27. So it's just a little classic grouping problem. So we're going to wall it down the middle here. Out of the left half, we're going to pull x squared, and that leaves behind x plus 3. And then out of the right half, we're going to pull down the minus, of course, and we're also going to pull a 9, and that leaves behind x plus 3. Change the sign. And again, I'm just going to kind of go a little quicker here. I'm not going to show the difference of squares because by now that's probably to the point where you're like, yeah, I see it. Like you see it coming. The yellow and green makes a difference of squares. So my final laid out factorization is GCF times commonality times difference of squares, which of course goes that way, like that. So when we lay out our answers for this, we do get a 0 at the number 0. And we do get, out of these two that I'm underlining, we only get one answer. it is at x equals -3. But remember, you need to just sort of parenthetically state that, hey, this has multiplicity of 2. That's an important part of your answer, is expressing multiplicity, okay? And then our last 0 is coming from this guy, and he is at 3. So that's an answer. Probably want to box that up, proudly put it on display. And then again, go and make your axes. So we need an x-axis. I really should have used my line tool there for that. Oh, that's so much better. And -3 and 3 are pretty symmetric, so I can just go kind of nearish the middle, which that really isn't, and mark them. So I have a 0 at -3, and then I have one at +3, and then I have one at 0. So we'll throw a quick label on those. We have a -3 here. We have a 0 and a 3. So that's that. And if you understand your end behavior, then you know how the bounce is going to occur. There is a bounce, like Tristan said, at -3. We just want to come at it from the right perspective. And that's where end behavior, again, bails us out. So when you look at the original problem, it's an up-up, because it's an even exponent with a positive leader. So it's an up-up. So if the graph has to go up-up, which is non-negotiable, then we know that it finishes through here with an up, right? And the bounce occurs at -3. So you kind of, sometimes it helps to get in and actually sketch the bounce before you begin trying to construct the graph like that. Kind of cheat it a little bit. And then you can finish off the up into infinity part like this. And then all the other zeros are just cut roots. So they're just, the next one is just going to come up. It's going to cut through 0, and then it's going to come back up, and it's going to just cut through 3. Because they're just single roots, they're just cutters. No bendies, just cuts. So I slacked a little bit and didn't color code. My bad. I shall fix. Yeah. So we have intervals. There are 4 intervals that we see here. So I have a negative interval. Let me scroll just a little bit here. So I have a negative over only one interval from 0 to 3. And then I do have 3 positive intervals. So I'm positive over the first interval as I come in from the left is from -infinity to -3. The second interval is from -3 up to 0. And then the last interval goes from 3 to the right, like that. Okay, halfway home. Any questions so far? Yeah. Yeah. Box everything if you want, but I'll find it, Sutter. I appreciate the sentiment, but honestly, I'm probably not setting the best example. It's usually a good idea to kind of box everything that you want to present, but honestly, I won't right or wrong you based on what is or is not boxed. So yeah, I probably should be boxing more, but yeah, I'll find it. Of course, with yours, I might need a magnifying glass and a flashlight and some LASIK surgery and something else, but I'll find it. If you guys have never had the pleasure of trying to look at one of his papers, well, put that on your bucket list. All right, number 3. It's not actually number. Oh, it is number. I actually numbered my problems. Look at me. I'm a big kid. All right, so our function, you should have pulled out a -3 on this one. And if you did that, then the leftover function is 9x cubed. We're on the third one, Corbin. Minus 18x squared, minus 16x, and plus 32. So the remnants, the white remnants are what we're interested in here. So without the GCF on this problem, you're really going to struggle. So we knew we had to get a negative at least, and then it turns out you can divide all those by 3. So this is just a grouper. So we're going to wall it right down the middle. And then the GCF on the left half is 9x squared, leaving behind x minus 2. The GCF on the right side is a minus and a 16, leaving behind x minus 2. And then my final factored out, so here it is all laid out side to side. Here they are. There's going to be a handful of factors. There's -3 times the commonality x minus 2 times the difference of squares, which again, that yellow and green, kind of a broken record here, difference of squares, factors into 3x plus 4 times 3x minus 4. There's no way we've made it this far into October and you're still not seeing differences of squares. It's almost just, it can't happen. So at this point, I see 4 factors. This one, the one I just slashed, does not count towards our answer, right? Remember, you have to have a variable to produce a 0. So he's just junk. Normally they're not junk, but if we're doing it purposefully like this, it's just junk. So throw it away, cross it out, whatever you want to do. So we get a 0 at -2. We get another 0. Do you guys remember how to come up with this 0? What is it? Yeah, 3's on the bottom. Good job, you guys. Negative, change, so change the sign, -4/3. And then this one's just his counterpart, right? A lot of times the zeros travel in symmetric pairs, opposites, right? Not always, but you see that a lot that they do. So yeah, why did I put -2? Did I actually put -2? I was going to say you can't prove it, and then I remembered I'm recording. So yeah, I can't lie. Thank you. It is +2. I don't know why I put negative. Thank you, Mason. So
it just was your ultimate self.
Yep.
Spiritually
End behavior on this one, since it's odd negative, is going to be up, down. So we're going to up on the left and down on the right. So that's the ticket right there. So now we're going to head down and sketch a graph. Everything I need is now on the board. So I'm going to make axes. So I need an x-axis, and I need a y-axis. And it's going to be just slightly heavier on the right, but not a lot. So I'm going to mark my first 0 at -4/3. And that's like equivalent to saying -1 and 1/3. So whatever. And then there's another one over here at the symmetric opposite, which is again 4/3. So if that's 1 and 1/3, then the next one is probably about there. What's up, homie? No, I don't mind at all. Nope, it's because it doesn't have an X with it. The only time a GCF will give you an answer of 0 is if he has an X or an X squared or something like that. If he has no variables, he's junk. It's important to get him out of the way so that we could do the factoring, but in this case, throw away. Good. Okay. End behavior is up, down. So if it goes up on the left, then, and there's no bounce roots here, so this is a pretty standard graph. So up goes this way, and then down's going to go to the right over this way. So this one is pretty predictable. You should not have struggled with something like this. If anything would have gotten you, it might have been the factoring perhaps, but the graph itself is pretty boring. So that's that. So because this, I'm sure dips way down. I'm talking like way down. I bet it dips down to like, oh, hello, keyboard. I bet it dips way down to like negative obnoxious number. So if you were to look at it on Desmos, you could certainly figure that out. So that's the graph. And again, we're not going for like perfect scale. We're just trying to get an idea of the intervals. So this graph is negative over, so I didn't label my graph either. So you should have labeled, but I'm looking at the clock and it's telling me I should probably just shut up. So make sure you label your zeros. Okay, dudes. So this graph is negative over the interval from -4/3 to 4/3. And then it also goes negative again from 2 to infinity. Right. And then the graph is positive on a couple of intervals. It's positive over the interval from -infinity to -4/3. And then it hits positive again in this little arch over here, and that's from 4/3 to 2. All right. Still good? All right. I do have 6 minutes, and I'm probably going to need them all, so stick with me here. We got to get through problem 4. Number 4 has a lot of meat on the bone. You do have to start by pulling out a GCF on number 4, so you pull out a 2. You also should have pulled out x to the 3rd, and that's going to leave you with x to the 4th minus half of 58 is 29, x to the 3 less is 2 plus 100. So what I tried to make for you here was a nice lookalike that you could factor down into a pair of squares, a pair of differences of squares, and that's what you should have found. So the GCF just sticks around, and then the big white thing factors into x squared and x squared. But again, I was going to say you can't prove it, but no, I'm keeping this one. Oh, I almost sang some Madonna there. I'm so glad I didn't do that, because that I would have to delete. You don't even want to know. So there's that. That's the factoring. So the laid out factorization is 2x to the third, and then we do have 4 factors incoming. So we have the x plus 5. Right. So, and the good thing about this is these, other than the curvy slice root at the 0, we have a lot of unique just crossers. So let's lay out the roots or the zeros. So here we get a 0 at 0 with multiplicity of 3. Here we get -5. Here we get +5. Here we get -2. And here we get +2. So we do have a lot of zeros going on. And a lot of zeros, sorry, means a lot of intervals. So, I mean, I wrote this problem, so I can't complain about it. So looking back at the original problem, it's an odd positive. So odd positive is down up. So this one goes down on the left and up to finish on the right. And now we can graph. So we need axes, x-axis and y-axis look pretty symmetric to me. So I'm going to go from -5. So mark your zeros. Again, I'm probably not going to label them, so don't get mad at me or anything like that. I'm just in a hurry. So there's -5, there's -2, there's 0, there's 2, and there's 5. That's all of them. 1, 2, 3. Yep. So end behavior tells me down, up, and there's no funky stuff going on over here on the left side. So it's going to go down just predictably like this. And then the up on the right, predictably, it's a single root, just a crosser, a cutter. So it's just going to go up like this. And now what goes on in the middle? The only real place we have to pay attention is at 0. So if you just kind of follow the graph for a while, there's not much activity here. Bless you, for a bit. It's gonna go down through this way, and then it's going to turn negative. But to make that multiplicity of 3 happen, you've seen this before. I should zoom in a little bit. It's going to kind of bend a little bit as it gets up to 0, right? Remember that guy? He's not a straight crosser. He's going to bend as he crosses. And then it kind of snakes out the other end, behaving the same way like that. So you see that little nice snaky curve? That's what odd multiplicities do. And then the rest of the zeros are all just unique. So it's just going to go down, and then it's going to curve back up. So that's what your graph should look like on number 4. So let me get through this real quick. I know you're starting to backpack band at me. So if you could just give me 1 more minute before you do this thing. If you pack your backpack, everyone else hears that sound and then they pack their backpacks. I just need 1 more minute, I promise. So this graph is negative over the intervals. I got to label these or I'm going to go nuts. -5, -2, 0 to 5 there. So it's negative over -infinity to -5. It's also negative from -2 to 0. And it's also finally negative from 2 to 5. And it is positive over similar, it's the same number of intervals. So from -5 to -2, from 0 to 2, and from 5 to +infinity. So that is that. We made it with like a minute and a half to spare. Booyah. I'll post the recording of this and also the answer key on there if you want to look at my work, which whatever. And then tomorrow you're going to take a quiz. Be ready. Probably 4 questions again, maybe 5, maybe 6, probably 4, but not 7 or 8. Definitely not 2 or 3, somewhere between 4 and 6.